And 10.3 worksheet problem number 16. Somebody had just asked about 11 through 19 in general, so I thought 16 was a good representative problem to use. They're giving us an excuse me, an octagon in number 16, and they're asking us to find the measures of the angles formed first by two consecutive radii, and secondly by a radius and a side of the given polygon. Those things are all connected. So in number 16, I'm going to go ahead and try to draw out an octagon, although really, once you get the hang of these problems here, you should not need to draw them out. All right, 5, 6, 7, and 8 sides. That's a pretty crappy looking octagon, but oh well, we'll make it work. All right, so that's what we have here. It's supposed to be regular, so all the sides and all the angles are supposed to be congruent. And they want to know the angles formed here by two consecutive radii and then a radius and a side. Okay, so the way we normally do this is we try to locate the center of our polygon, which I'm just going to guess is located right here, and I'm going to draw the two radii that go down to the bottom side here. So that's one radius, and here's going to be another radius right next to it. All right, and the angle formed between two radii is what we normally are going to call theta. And I've done this now 3 problems in a row. The way that we always find theta, you guys, is to take the sum of all your central angles, which is always going to be 360, and divide that by the number of central angles you have, which is going to be equal to the number of sides. So in this case, n is going to be 8, and 360 divided by 8 is going to get us 45 degrees for the measure of this central angle right over here. That's theta. And let's go back and read the problem again. The first thing they wanted to know is what's the measure of an angle formed by two consecutive radii? Well, that is exactly what we found right here. So the answer here, guys, for part A to this problem is going to be the 45-degree angle that we just came up with. Okay, so we're half done. The second thing that they asked for, and I think we're going to switch to a lovely shade of pink right here. Let's try that. All right, we're going to try to find also the measure of an angle formed here between a radius and a side of the given polygon. So the radius we're dealing with is right over here, and the side of the polygon is going to be down here on the bottom. So now what we're interested in is this angle right over here. And there's a couple of different ways to do this, but given the fact that they didn't ask us anything about an apothem in this problem, and we're not finding the area of it, so we don't need the apothem at all, I'm going to leave that out of the mix completely, and I'm just going to focus on this entire triangle right here that I've got in this pink or purple or whatever you want to call it. And what we hopefully recognize here is that this triangle is going to have one radius over here on the left and another congruent radius to it over here on the right. That makes that triangle isosceles. And an isosceles triangle has two congruent sides, but it also has two congruent base angles here. So this angle and this angle always have to be congruent. And we know that the measure of our central angle in this particular problem, not always, but in this problem, is going to be 45 degrees. So that should help us figure out the measures of these two angles right here. The first thing I'm going to do, guys, is know that the sum of those three angles is 180. I'm going to subtract the 45-degree angle from that and get 135 degrees left over for these two angles to share. And since they share it equally, I'm now going to take that 135 and divide it by 2 and get a 67.5 degree angle for this one right down here and this one right over here, 67.5 degrees. And right there, guys, we have the measures of all three angles within our isosceles triangle here. So again, just to make sure I've got this right, part B to this question was asking us for the angle measure between a radius and a side length in a polygon. There's our answer right there of 67.5 degrees. So that's how you're going to do problems 14 through 19. The only real difference is that n is going to change value in every one of these problems. For example, in number 14, you're dealing with a hexagon, so n would be 6. In number 18, you're dealing with a 15-gon, where n would be 15. So that's the way you handle those 6 problems.